Hello and welcome to Sir Dave's Maths. In this video, we shall be looking at how to solve simultaneous equations containing one linear, one quadratic using the graph method. One linear, one quadratic using the graph method. So we have an example here. I'll just give you a minute to go through the question. So we find that to plot this graph, this quadratic function, we need to prepare a table of values. So using this interval -3 to 4 for our x values, x -3, -2, -1, 0, 1, 2, 3, 4. Then we have 2x squared -3x and -7. We have our y here. So what would this value be when you have -3 as our x here? So when x is -3, 2 brackets -3 squared. This becomes 3 minus 3 squared is 9. 2 times 9 is 18. Where you have -2 in place of x, this will give you 8 because 2 times 2, that's 2 squared, is 4. 4 times 2, 8. This will give us 2 because 1 squared is 1. 1 times 2 is 2. 0 will give you 0. 1 will give us 2. 2 will give us 8. 3 will give us 18. 4 will give us 32 because 4 squared is 16. 16 times 2, 32. So next we have -3x. -3 times -3, this will be 9. -2 times -3, 6. -1 times this, 3, 0, -3. 1 times -3, 2 times -3, -6. 3 times -3, -9. 4 times -3, -12. Here we have -7 because it's a constant. There's no variable attached to it. Next, we'll add this plus this plus this to get this. This plus this plus this to get this. This plus this plus this to get this. So 18 plus 9, 27. 27 minus 7 is 20. 8 plus 6, 14. 14 minus 7, 7. Here we'll have -2. Here we'll have -7. Here we'll have -8. Here we have -5. Here we have 2. Here we have 13. Alright, so that's for the table of values. We're going to make use of these two values to plot our quadratic graph. So first of all, we'll mark out those points and then we'll make use of a flex curve, a French curve, or even a broomstick to plot our quadratic curve. So let's mark out those points using these values. So back to our scale. For every 2 cm, you have 1 unit on your x-axis. So this will be 1, This will be 2, this will be 3, and this will be 4. For your y-axis, for every 2 cm you have 5 units. This is 5, this is 10, this is 15, this is 20, this is 25, and so on. -5, -10, -15. For your negative x-axis, you have -1, -2, -3. So when x is -3, y is what? 20. X is -3, y is 20. This will come this way because when x is -2, y is 7. X is -2, y is 7. This is 5. This is, if this is 5 and this is 10, then it means that this is 6, 7, 8, 9, 10. So each of those two smaller boxes is 1. Each of those two smaller boxes is 1. So from here to here will be 6, 7. So go this way, mark it here. When x is -1, y is -2. X is -1, y is -2 is down this way. So -2, this is -1, -2. When x is 0, y is -7. When x is 0, y is -7. This is 5, this is 6, this is 7, -7, so it will be here. When x is 1, y is -8. This is 1, this is 7, this should be 8. When x is 2, y is -5. When x is 2, y is -5. When x is 3, y is 2. When x is 3, y is 2. This is 1, this is 2. When x is 4, y is 13. When x is 4, y is 13 upwards. This is 10, 11, 12, 13. So we have our points. It's time to join those points. I'm going to make use of my broom to link all of these points. So we have our curve neatly drawn. The next part of the question says, draw on the same graph the line y equals 2x minus 1. For this, we are going to prepare another table of values, and then we'll draw this straight line because it's a linear function. We'll draw this straight line on this curve, on this same graph. So when x is -3, Y becomes what? Two times minus 1, 2 times minus 3, minus 6, minus 1. This will become minus 7. If you continue with this pattern, this will give us minus 5. This will give us minus 3, minus 1, 1, 3, 5, and 7. So let's draw the graph for this function. When x is minus 3, y is minus 7. When x is minus 3, y is minus 7. This is 6, this is 7. Y is minus 7. So this will be somewhere here. When x is minus 2, y is minus 5. X is minus 2, y is minus 5. When x is minus 1, y is minus 3. 1, 2, 3. When x is 0, y is minus 1. When x is 1, y is 1. When x is 2, y is 3. 1, 2, 3. When x is 3, y is 5. X is 3, y is 5. When x is 4, y is 7. 6, 7. So having plotted these points, we're going to draw a straight line through these points. So from the graph, this linear equation intersects or cuts this quadratic curve at these points, here and here. So if you trace this value to your y-axis, you have approximately 6 here, and then if you trace this value to your x-axis, you have approximately 3.4. For this side, if you trace this value to your x-axis, you have approximately 0.9. And if you trace it to your y-axis, you have minus 0.9. Here you have minus 2.5. Now, if 2 cm will give you 1 unit, it means every little box here is 0.1. So I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. And we have almost 0.9. So I said approximately minus 0.9. So please try your hands on this particular example and see what value you get.